All right, so as an example here, and let me write our binomial probability formula up here again. So the probability of x successes is going to be NCR, so a combination of n choose, not r, it's x now, n choose x. I knew I was going to do that eventually. And this is going to be times the probability of a success times x, because we have x successes. The probability of a fail, that's 1 minus p, and that is going to be n minus x. Is going to be the power, so that's my number of fails. So a multiple choice exam is designed such that there are 10 questions. So I have 10 trials, and each question has only 4 answers, only one of which is correct. So we're going to figure out probability here in a moment. What is the probability of getting 7 out of 10 correct? So I'm looking for correct answers. So a success is a correct answer. A success is a correct answer. There you go. So what this means is each question has one answer is correct out of 4. So the probability that I would just randomly guess one of those answers and I was successful, it was correct, is 1 out of 4. Okay, so the last part we need is what is the probability of getting 7 out of 10 correct? So this means that I want 7 successes. So my x is going to be 7. If I go back and I do this probability, so I want the probability of 7 successes. I have 10 trials, and I want to do a combination of 10 of choosing 7 successes out of 10 options. So choosing 7 out of 10. The probability of a success is 1/4, and that is going to be to the power of 7. A fail is going to be 1 minus the probability of 1/4, 1 minus p, and that's going to be to the power of n, which is 10 minus 7. So we're going to see that maybe we could kind of skip some of these steps here and go a little quicker, but my combination of 7 choose 10, I'm sorry, 10 choose 7, and then we have that probability of 1/4 to the power of 7, and then my fails is not 1 minus 1/4. The chance of a fail is 3/4, which makes sense because I have 3 that are incorrect out of my 4 answers. And I have 10 trials. I'm looking at 10 questions. If 7 are correct, then what's left over is 3 would have to be incorrect. I believe that's 120. I'm just double checking here. So 10 to 7 for a combination. That means I have 120 ways to choose 7 questions out of 10. And this is time 1/4 to the power of 7 and 3/4 to the power of 3. Put that all in my calculator, and I'm going to get approximate probability of 0.0031 or 0.31% chance. The next question is going to kind of lead us to where this is all going in the end. The primary reason we want these probabilities is a lot of times what we're looking for is what do we expect to happen and what do we not expect to happen. So unexpected things can happen, but we don't, because they're not expected, we tend to ignore them. Because we're trying to make a good judgment here based on the math. So if a student did get a 70 on a test, would the instructor expect that grade was gotten by random chance? I would say no. The probability of getting a 70 by random chance or randomly guessing because that's also what we mean, I'm randomly guessing, is 0.0031 or 0.31%. This is a less than 5% chance of happening. So remember, if anything has a less than 5% chance of happening, that's when we start considering unusual. So this has less than a 5% chance of occurring randomly. So it is unusual and not expected. Could it happen? Yeah. That's the chance it could happen. It could happen. The thing is, like what we're saying here is that if I did get a test and there was a 70% on it, I would assume that the student probably studied and didn't earn a 70, and it was not because they randomly guessed. There are lower probabilities would make me go, well, maybe it was random guessing. So as an example, let's say, sorry, I got my numbers in here. Like, let's say they got only 2 correct, so they got a 20% chance, 20%. That has about a 30% chance of happening. That is a pretty good chance. So if somebody gave me a test and they got only 2 correct out of 10, I could easily assume that they were probably, it's possible they were just guessing. Do I know that for sure? No, but I'm just, looking at the probabilities of what was likely to have occurred. And it's not likely that by randomly guessing that you would end up with a 70 on this quiz. It could happen. Strange things happen, just not likely.